So thank you for being here. Um, um, it's been an interesting day so far in Riga, and I really wanted to make an introduction in Latvian. So forgive me if I'll say it terribly. I can remember is Lava Diena Bizim. Hopefully that was like good day, everyone. My original language is Spanish, so I'm terrible at languages. Anyway, the topic of today is JSR377. What's up and what's next? For those that you don't know, JSR377 it's a brand new JSR, kind of new, that tries to come up with an API for standardizing desktop and embedded application development. So it's not just, I think that on the program it was listed as IoT and embedded devices. Of course, we might cover some of that, but it's mostly on the other side as well, desktop. So this is me and my wife enjoying some time, really nice time in Montreux in Switzerland a couple of years ago. We traveled around the world talking about technologies that we use in our daily work. And for the past 2 or 3 years, we have at Canoe, this Swiss company, we have been doing a lot of development related to desktop applications. And we have done some developments also on the embedded space. And this is where we came out into the notion that there is not really out there a good set of APIs or a good set of frameworks that could cover the capabilities or deliver the capabilities of writing an application in almost in the same way as you would do for a server application right now today with the Java EE. So we're missing this thing, and this is precisely the reason why JSR377 came out. So though some of you might remember a little bit of the history, I'm going to go quickly to this. There was one attempt in the early days called JSR 193, client-side containers. So Java EE already existed when this JSR came about. It was pretty much the same idea. If you have a container on the server, you will have a container on the client. For some reason, this didn't come to fruition, and some years later, we got JSR296, also known as a Swing Application Framework. Many people were excited about this one, myself included, but for some reason or another, it never came out to be realized in its final form. We also got JSR295, which allows us to have beans binding or property binding. Now, these two things are important because you might remember that around, this was in 2006, 2007, and then Sun, at the time, made a big announcement in Java 1 2007. JavaFX, all the screens of your life. Use any embedded device, put the Java on the airports, put Java on the space everywhere, and well, it actually didn't happen as they expected. But the idea of JavaFX was rooted in some of the concepts of these two JSRs. So some of the goals of 296 were to deliver a common way for you to define actions and to locate those actions and configure metadata about those actions. We have to remember by the time this framework or this JSR was proposed, struts was the king of the web frameworks. Does anybody here remember struts? Right? Yeah, we got actions and forms and whatnot. So that's precisely what they did it. And we also needed a way to localize resources. And if I'm not mistaken, localized resources also enable some other people to come up with ideas that turned out to be JSR 330 dependency injection, besides Spring and Use and the other frameworks. So it was a little bit of cross-pollination within the different JSRs and what has happened at the time. But something happened, 296 never came about. And one thing that I would like to say is that when we proposed this JSR 377, we were hoping to get 399. Because if you see the national progression of numbers, 193, 296, the next one should have been 399. But we didn't. We got a 22% discount or so. So, were you writing applications for Java on the desktop and embedded devices? You're quickly faced with this decision. Which UI toolkit do you target? Swing is the default one, or used to be the default one for a long time. We're not going to talk about AWT, it's really old, and it doesn't run on many devices. Swing has the capability to run on more platforms, but is aging and is no longer maintained. JavaFX is the next version. It's not yet a full replacement, but it's really heading into that, and it's capable of running on embedded devices, not just a Raspberry Pi, but also the BeagleBoard and Arduino and many other things. So apparently this toolkit can give you much more access to different platforms. Or if you ever did something with C and C++, you might have used Qt. There is this open source project called Qt Jambi, which allows you to use Java to drive the Qt toolkit. Unfortunately, Qt Jambi is not up to date to the latest versions of Qt, but this is just the very nature of open source. Apache Pivot, it was posed as kind of like a direct competitor to JavaFX. It had also its own way of working. It doesn't work with many platforms out there, at least not the embedded ones. It is based on AWT. GTK only if you're on Linux, and there's also SWT, which apparently works in many platforms, but it has its own host of problems because it requires you to run native widgets. So it has a strict tie to a particular platform. It makes deployment a little bit more difficult, but of course it's possible. There are many applications out there that make use of these toolkits. The next thing that we have to consider is when you're writing this application is it enough to just target the desktop? So far, until a few years ago, everybody was doing either a rich application or a web application. But these days, we got mobile devices. And we got this smaller computer, the Raspberry Pi, and we got Arduino and BeagleBoard and many other things. These devices are great for hooking on sensors and consuming that data, and the next thing that you want to do is visualize that data somehow. In the past, given that these devices were constrained in their computing power, we'll have to be concerned only by reading the data and then sending it to a different device, a much powerful one, so that we can visualize it. But these days, we can do and we can run the visualizations inside the devices. So that gives you much more options. Out there, we got a handful of frameworks that already deliver one of the or some of the capabilities or the features that I would like to see in a standard way. I have separated in kind of like 3 layers. One of them is the first layer is the big frameworks or the big platforms where you will find the Eclipse RCP platform and the NetBeans RCP platform. These frameworks and platforms give you a lot of services, a lot of behavior with a little configuration, or at least that's the promise. The problem with these RCP-based applications is that they tend out to be very big. If this is a problem when you want to deploy to smaller targets, to smaller places. It's not a problem where you're building a big application for an oil refinery or for a military customer. This is one, perhaps the customers that make most use of these platforms are precisely those that we don't hear too much. Those that are behind research institutes or military or is there somehow related to the governmental offices? Because what they need is closer access to the metal. It's very hard. It's not impossible, it's very hard for a government office to say, we're just going to run something that is mission critical using a web application. So no matter how much hype is out there on mobile or web, there's no way that many of these organizations will simply switch to using browser-based applications. So there's still a big market for building rich applications and embedded ones. It's just that the hype is not that much as with the other ones. Next, we got another layer, which is the set of frameworks that give you access to building medium-sized, small-size applications. And if given there is enough configuration or enough extensibility points, then you can reach up to the levels of the RCP platforms. You got a Griffon and a Basilisk and Gluon, which actually runs also on mobile devices. And JavaFX, most of them are now targeting JavaFX UI Toolkit specifically because JavaFX has been announced as the replacement source swing. Now, I must say something here immediately, which is, in terms of full disclosure, I am the author and the lead project lead of the Griffon framework, which delivers many of the features that we would like to see in such API. So in a way, this framework has served as an inspiration for the API that we're going to see next, but it's not the only one. In the expert group of JSR377, we have lots of members, and some of them come from the Eclipse RCP team, others come from the NetBeans Dream team, some others are Java champions that are known to work with all the different toolkits. So we got a good mix of input coming from different places. Common features that are found in these frameworks. Some of them, if you we look back into the previous slides from 296, are found here. So all of them have an application lifecycle, just like in a standard web application, there is a phase where you are initializing, or at least your beans have a pause construct method, so you know that things are getting started. And there's also a way for you to define a lifecycle call when your objects or your beans need to do some kind of cleanup. Typically, this is a pre-destroy. But in the case of an application, you need a little bit more than that. It's not just the beans or the instances that do their proper lifecycle, but the application itself has to go through certain phases. Localized resources and injection. Building an application with dependency injection today, 2016, doesn't seem like a good idea, especially when you're going to a mid-range application. We don't need to reinvent the wheel. We just can simply consume existing JSRs, such as 330. Some of them provide you with the capabilities of persistent session state, which means you are working on something, your window has some certain size and it's in some location and course on something like that is specific to the application. You shut down, you bring up the application again, and your application is in the same size, same location, whatnot. This is what we mean by persistent session state. Loosely coupled actions. So there should be a way for you to define behavior for that can be attached to a button or a checkbox or some other UI widget, and that you can reuse the same behavior in different places, and that you could define some metadata. For example, what is the name of the action that can be used as the label when displaying it to a particular widget, or is it the colors, or is it the enabled state? So this is what we mean by these loosely coupled actions. Dependency injection again, an event system. Many applications rely on the fact that when you're constructing the components, then they know each other, so they are tightly coupled. But in the coming years, or at least in the recent years, we have started to build applications with event systems baked in, or event buses. So these frameworks already provide a very lightweight event bus that you can use to have components talk to each other without having them to know each other directly. Centralized error management. You guys let me know if this has happened to you, but at least this is a real use case scenario when I used to work in a different company. We have a big product that everybody will use, and from time to time, well, we will encounter errors and unplanned exceptions. So while we're doing development time, if an exception happened to occur during the execution of the tool, there will be a new dialog that will appear. It will pop the stack trace of the current exception, give you some hints on what you could do. Perhaps there's a list of steps that you follow in order to encounter this particular problem. Click submit, and that will create an automatic ticket, an issue in our issue tracker. Easy. But what happens when you ship the tool to your customers? Well, the issue tracker should not be part of production. So we needed a way to hide this thing. And through the usage or the idea of environments and through the usage of a centralized error management, we're able to give the final customer a different view of the problem. Maybe it was just a simple dialogue such that said, an unexpected error occurred. Would you like to save your changes because we need to shut down, or do you want to shut down immediately without saving any changes? But if you were to run the same tool with a different environment inside the firewall perhaps, then you get the dialog that will pop up the full stack trace plus more information so that we could fix the bug. And finally, of course, these frameworks can think of many things to do, but they cannot think of all possible things that you as developers need to have in order to create the best experience for the application. So these frameworks and these platforms need to provide you the capability to extend the frameworks so you can hook in wherever is needed. Does that particular framework that you chose expose security concerns? Probably not. But it does expose an extension point for you to say, now I want to validate all actions with some security restrictions before they're executed. That would be much better. In this JSR, we want to target two environments. I mentioned the primary one may be desktop. That is because it has been more prevalent in the last years. But we also would like to target embedded devices. Pretty much anywhere where Java SE can run. So the goals of this JSR are targeting these two environments, support for several UI toolkits. 296 supported only one toolkit, even though by the time that it was created, there were already 4 UI toolkits running inside the JVM. Only one of them came bundled with the JDK. We want it to be a standalone JSR, which means we will not be tied to a particular JDK release. So if we finish this JSR, the final draft in time, then we can release it just when it's ready. We don't have to wait for JDK 9 to be ready. We don't have to wait for JDK 10 to be released because it's definitely a few years from now. We also would like to leverage existing JSRs. The first one that comes to mind is the dependency injection JSR. It's very easy to use. There are many implementations out there that we can just reuse, and people can plug in whatever they need. CDI 2.0, which should come out sometime next year, is supposed to break down into smaller pieces, and one of them is the event bus. I think that when we started this JSR, the idea was to reuse exactly that API. But because now we know the target dates of release for CDI2, we can no longer use this API. What we can do is design an API that looks a lot like the CDI. So maybe in the future, somebody can come up with a bridge extension that can reuse CDI if you are building a huge application with CDI-enabled dependency injection. Or at the very least, what we want to do is ease up the migration into one environment to the next. So these are the core features that we would like to see in this JSR. These are pretty much exactly the same we saw in the previous slide, except there is one additional one, which is right there, is the MVC artifacts. And what do we mean by this? Many applications require you, or it would be great if you can separate concerns when you're building these applications. You always have a view. This is the component that provides the UI widgets, the UI for your application. But it's also recommended to split the UI and the logic. So this is when the controller or presenter appears. And some people would like to have somebody in between the view and the controller, which is the one that holds the data. This is called the presentation model or just a model. So this is where MVC comes around. But I also mentioned presenter. Some people don't like controller, so there's another MVC pattern out there called model view pattern presenter. But it's also true that it's model view view model. And there is also true that is out there is presentation model view controller and presentation model adapter. So if we say something like MVC, what we want to say is the stereotypes where behavior can be found. But we don't want to say explicitly it's just one MVC pattern. So we're not proposing just controller when you actually want to do is a presenter or a view model. So this idea should be wide enough for you to pick up a variation of the MVC pattern that fits your needs. Out of the scope for this version, because we would like this JSR to have more than one version, just like it happens with Java EE, are the following things for now. We don't need to come up with a persistent session state in the API itself. The implementers can do it on their own. Artifact introspection API. If you start to think about artifacts such as model, view, and controller, the view can have some basic life cycle. And the controller can say, these are the actions that I have. And the model can say, these are the observable properties or the shareable properties that these two elements can talk with each other. So these kind of the things that you can answer, or the questions that you can answer with an introspection API. You have a model instance. Which properties do you expose? You have a controller instance. Which actions does it make sense for this thing to actually be called? And finally, a specific UI toolkit updates. So because we're talking directly to an UI toolkit, it could perhaps make sense for some to add new widgets, to add a specific support to call something inside a specific thread, or to call into a specific API of a particular toolkit. We won't be able to do this now because as the first time we want to be completely separate, completely UI toolkit agnostic. We don't want to marry this JSR to a particular UI toolkit right now. And in terms of build time, these are the two things that actually come up a lot. One of them is, okay, I built an application. Great. How do I test it? Do I just do unit testing? Yeah, that's easy, comparable. Do I do integration testing? Why do we mean by integration testing? Do we test just the controller and the model and the services? What happens with UI? How is it possible to drive the UI directly? Well, it depends on the particular widget set. And again, this will marry the particular API to a specific widget set or UI toolkit. So this is the reason why we leave it a little bit, but what I can say is a set of guidelines that will allow implementers and developers to do the right thing. Finally, deployment. This has been a thorn when developing desktop applications. Some try to fix this problem with Java WebStart. How many of you actually used WebStart before? As a consumer?
Yeah, it works very well.
It works very well. Thank you, Nicholas. But the reality out there is that not that many people rely on WebStart, especially perhaps internally inside organizations, because the good thing is that you can constrain the environment. But if you want to really deploy this into the wild, say for example the IDE vendors, what if they wanted to deploy give you the capability to have the next version of the IDE through WebStart? Simply no way that this is going to happen. So is there a way that we can do to help deployment? Not right now, because applications right now are built in many ways. They can be started in many ways. They can require many things before they can actually be launched. But if we have the first set of standard APIs, if we have a standard set of application phases and lifecycle, then after this step, we can think about standardizing on deployment. So now I'm going to turn into show some slides with code. And let me say that what we have come up so far in this API has been discussed inside the expert group. But people are encouraged, people that are not members of the expert group are highly encouraged to give us feedback, because this JSR is actually dual license. It's using the standard JCP license, but it's also using Apache 2 license. So if you are not a member of the expert group and you would like to contribute code and ideas, you're more than welcome, knowing that your contributions will be made under the Apache 2 license. If you decide to really contribute forward into JSR, then we will encourage you to really join the expert group, because that gives you more capabilities, it gives you more power, and it makes greater the experience with the expert group. So without any further ado, one of the first things that we find is that every application has to have a specific set of I know, lifecycle phases. Now, this is true for both desktop and embedded devices. So you always have to, somehow to kickstart the application. This will be the initialize phase. This will make sure that you are, I don't know, you're reading resources, you are initializing the dependency injection container, what is basic in order to get the application off the ground. Then the next step is the startup phase. This is when you really get that application warm. If you are relying on MVC artifacts, this is when you start to put everything together. If you are relying on establishing connections to a database or a remote server, this is where things start to do. This is when things start to happen. Then we switch into the ready phase. This is, okay, all the startup is finished. I'm ready to do whatever is necessary to show the first screen or the first window. Or in the case of Android, that will be the first activity. Now, immediately, you turn into the main phase. This is where the application runs for most of its time. Anything can happen here. This is exactly what the application has been designed for. At any point in time, the application must shut down. In the case of desktop, that is very true. You simply call quit, perhaps. And then you go, there goes a very well-defined procedure where resources get deallocated, connections to the database and network just close down gracefully. We persist a state perhaps, and then we go off. Now, in mobile devices or embedded devices, you might have seen two other lifecycle phases: pause and continue. Now, these two are very specific to this environment, and for the time being, we are trying to come up with what is common within the two environments. So that's the reason why pause and continue are not listed here, because they do not make sense for a desktop application. At least not now, until we start running desktop applications just like we do in embedded devices, where you just double click here and then it's gone, it passivates the application, then perhaps, but at least not in this year. Then we find the application interface. This is the main entry point. This is the one that will orchestrate everything together. This is the one that implementers need to supply so that you as a developer just simply go hook into the particular set of events of life cycles. So there is a correlation with the names initialize, startup, ready, and shutdown. Notice that there is no main, makes no sense, because after ready, you go directly into the main phase. The shutdown case is quite interesting, because at least in the case coming from Eclipse RCP, this is very true. When the application shuts down, it may indicate that on the next boot up, it might need to do some updates, or that it wasn't shut down gracefully. So the state object, right, that particular type, will encapsulate an integer, basically. That will be used to signal down to the runtime process if the application is to shut down gracefully, or there is another application-specific number that makes sense, again, for that application for the next time it butts up. You could have also a series of these kind of types, the shutdown handler, that allows you to customize whether your application is ready to quit or not. The typical use case for this is that somehow you got an abstraction perhaps of what is a workspace, where you keep track of working data or a set of objects or domains that you have touched so far during your work. And when you input the sequence for quit, then your application will automatically shut down unless there is this particular shutdown handler that asks the workspace if it's dirty or if there's some unsafe changes. So this shutdown handler can immediately pop up a dialog telling the user, wait, you have some unsafe changes. Are you really sure you want to quit or not? This is the most basic use case for this. Here are those two types. There's the shutdown handler that has two methods, very simple, and there is also the exit state where, as I remember I was telling you about, this is mostly just a wrapper around an integer code, and that's basically it. We cannot use an integer directly. We cannot use an enum. That will probably be the first design choice, because that particular value right there is application specific. There's no way that we can be able to use an enum. But an implementation of this type could do it with an enum, if it makes sense. We got some additional properties that you can find on an application. For example, where is the reference to its configuration, however it may be. It doesn't matter what format it has. It doesn't matter if it's persisted using XML, JSON, YAML, or it's in the database, or it's somewhere else. At least it has to give you the basic capabilities to query keys and give you the values in the right types. We were expecting at this time to be able to reuse the JSR for Java config. Sadly, this JSR never came to happen. So for now, what we had to do is keep track of another project that exists out there. It's called Apache Tamaja. It's started by Anatoly Tresh, the author of what it was supposed to be the JSR for Java config. So we know this JSR, or at least this API, is quite good, and it's possible that a future implementer of the JSR377 could reuse Apache Tamaja as is. You got a link to the face, and perhaps you can think about the locale, if it makes sense to keep track of application-specific locale, which is different perhaps from the process locale, the current JVM process. And, of course, any startup arguments that you might want to pass to the application. Next, we're going to threading. Now, who of you remember what is the golden rule of swing? We're working with different threads. There is one simple rule, and everybody breaks it because it's so easy to break. There is no protection against it. Whatever, exactly. So what Michael is saying is that don't do any work in the UI thread. Specifically is anything that is related to the UI. So reading and writing properties of a widget has to happen inside the UI. But everything that is not that, so regular behavior such as opening a database connection or talking to a server, that has to happen outside of the UI thread. And because it's so easy to break this rule, people did it for years. And we saw many times that gray rectangle in a Swing application, because the moment that you click a button, somebody opens a connection to the database, and it takes time for that to pass, and the UI cannot run. And they say there's this wait timer decorator, which is stop, because the UI thread is handling the database results, right? So this is a breakdown of different ways of handling the UI with different UI toolkits. And the most important ones perhaps will be Swing, JavaFX, and SWT, because these are the widely used UI toolkits. All of them give you capabilities to find out if some code is running inside the UI thread or not. This is great. Almost all of them give you the capability to execute some code synchronously inside the UI, which means you post an event inside the UI thread and you wait for the UI thread to finish working with that so that you can get the results. JavaFX does not allow you to have this publicly, but it's private API to make it happen because you effectually need this behavior. The JavaFX team decided that this is API that should stay off hands of people. I am completely against this decision, but I do not work for the JavaFX team. But there are ways to get around this. You can use a countdown latch or some other concurrent synchronizing mechanism in order for this to happen. And that's exactly how many of the tool frameworks that work with JavaFX have done it. And finally, you can also have the run async method or execution, which allows you to simply post an event into the UI thread and return immediately. The caller doesn't need to wait for the other code to finish. It just happens whenever it needs to happen. Pretty much every single UI toolkit supports that except Lanterna. Now, I didn't showcase Lanterna in the list of UI toolkits because it doesn't receive much press, but if you ever had the need to write a Java-based application that runs on the server or a very low client capabilities, if you ever saw end courses on Unix, that's exactly Lanterna, 100% Java implementation of something that looks like end courses. They don't need this capability. So in order to abstract how you deal with UI, these are the simple 5 basic methods that we can come up with. If you are running inside the UI, definitely it's right there. If you want to run something outside the inside the UI but in an asynchronous mode, just supply a runnable, done. Or if you want to run synchronously, just give another runnable. But because you're running synchronously, you can grab the result immediately after that. So we got also support callable. And the final one is, do we run something completely outside? How is going to be done? Implementers could use a simple thread, or they could use an executor service. So it's up to them. Now, some of you might be thinking, Andres, it's 2016. Java 8 has been released already. Why are you not making usage of the great APIs that come with JDK 8, specifically completable future? Would it make sense when you are launching an asynchronous execution inside the UI thread that you somehow are able to grab a result out of that? That's precisely why completable future exists. It's kind of like a promise in Java terms. Well, the reason why we are not proposing yet to use completable future is that mobile platforms are not up to the pace of being able to run Java 8. So if we were to release this API very soon, then these mobile devices will be out of the game until they are upgraded, which we cannot control that. So the design of this API so far has been done taking into account JDK 7 source compatibility at the moment. But such as completable future of optional or any other JDK 8 specific feature that makes a lot of sense or that can give us a much better advantage in designing the API, then we'll actually take it. And then we'll simply say to everybody, it's JDK 8 as the minimum, and the implementers should be as fast enough to give you access to what you actually need to run in those particular environments. In terms of internationalization, there are many things that we can do. This thing is a little bit inspired by Spring message sources. Anybody here, any Spring users? A few hands. So you know that you can give a key and you can give a default value, or if you give a key and then you might get an error if it's not found. You can also supply additional arguments. Maybe it's an object array or it's a list. And you might supply a locale instead of the current default locale, then you want to use a different one. So the basic method right there is get message, and you can think there are many combinations of all those 1, 2, 3, 4, 5, no, actually 4 different arguments. So if I were to show the real message source definition, it contains like 15 methods or so, but this is just the basic one. Coming from JSR296, we got something that was really neat. The ability to have, for example, like a model class, or maybe it was a view class, that could have some fields with types. So, for example, it was perhaps a color definition or a gradient or some kind of pattern. And you would like to externalize this information. It doesn't matter if it was properties, XML, JSON, some other format. It's completely outside of the code. And you would like those values to be injected into the running instance, and if needed be, to be transformed from that literal string into the particular object. This is exactly what the injected resources did in 296, and this is what we want to also bring into this API. Say that with this annotation, what you want to do is give the hint to a particular field or a setter. It could be also using setters, that for that particular type, you want to associate a key, which is found in the resources that the application knows how to locate. And given the type of the object or the type of the target, you may have access to converters or property editors, wherever the implementer decides to choose. So if you have that annotation, then usage of such annotation can look like this. So the most basic case is that, well, there is no key right there. So what's going on? We're going to use also sensible defaults. If there is no key, then the key is actually comprised of the full qualified class name plus the name of the field. And if I need to convert what I just read from the resources, I got all the information I have here. But if I don't, then I can supply additional information. Perhaps it might make sense for the injector resource to also have a link to a class that could be served as a converter type in case that this thing is not already registered with Implementor. I don't know. We are still discussing if that particular converter has to be there or not. But at the very least, the key, the values, and the way that I show here, if there are additional arguments for you to resolve this as if it were a message, so you can parameterize the key. These are the current resources. If you are more interested in finding more information about the JSR, the official page of the JSR is this one. Is found at the JCP.org website. And our GitHub repository, where we change code, is found right there. Well, this is the name of the organization. This is where we host in the API. This is where we host the reference implementation, and where we will also be hosting the technology compatibility kit. This is where you can see what we currently have, and if you are interested, then we would like to have your feedback, and you can even contribute code. Again, let me remind you, your additional contributions will be governed under the Apache 2 license. If you join the expert group, then it will be under the JCP license. The website is also found in this particular organization. Right now, we are using this name. We have to find a catchy name for this JSR. Desktop Embedded Application API is not really useful when you want to just say something quickly. For example, JSR354. Does anybody remember that JSR, what it is? No, but you certainly remember Java Money. Java Money is JSR354. See? So we need a name for our JSR. And this logo is the unofficial official logo. We probably should have a contest to come up with a logo for this. And so with this, we still have some time for questions. So yeah, thank you very much. But I'm going to leave the slide for the resources for you to have a look. And we're still very excited about this JSR. It has taken us a bit more time than we expected to come up with a set of APIs that we need. And well, the interesting thing is that even though we got a lot of, let's say, points of inspiration for coming up with the APIs as the frameworks that I listed before, we still haven't decided in some areas where this is really convenient to standardize on this particular thing or the other. The real advantage of this JSR is that we got real code, real frameworks, real applications that have all these needs. The other way in Java EE, at least in the beginning, they came up with a standardization of something that really didn't exist. But now we got something that we can base upon. And it's just a matter of picking the right pieces to make sure, yes, these things can be connected. And hopefully in the future, perhaps it will be sometime this year, that we will see the first implementations and the final release of this JSR. And for this, I would like to enlist your help. If you're really interested, let us know. Any kind of feedback and every kind of feedback, you don't like the API, you think this is good, this is bad, just let us know, because what we want is to make a much better experience for people like yourselves and like myself that write these kind of applications for a living and for fun. So thank you very much for listening. If you have any questions, I'll be very happy to take them. A question over there.
Hello. Back in the days when web was not yet that popular, when it had a lot of desktop applications, basically, and when the web started, some technology companies started to write frameworks that could have generated desktop application and web application from the same code. Then the web kind of went its own path. But now when we have a lot of single-page applications written in JavaScript and a lot of stuff is going on inside the browser, basically, do you think there is a place or option for actually using this API, so in general having a framework that can be used to generate clients for native desktops and for web at the same time? What do you think?
Yes, definitely, because what you will see in the web application is mostly a request response lifecycle. Yes, it is changing, but for most of them, it's request response lifecycle, which is not compatible with what we have access to the desktop, which is components. In the web, we got the promise, and it's starting to happen, web components. So they want to provide something that we already got on the desktop. It may be the case in the future, depending on how web components turns out to be, that we can have a much better unified experience within writing a desktop application and a client using a more common code base. But right now, web components is still a standard is in under development. Polymer breaks in one framework, in one browser and to the next within releases. So it's still a moving target. And we cannot wait for this moving target to finish. So we need to do something now, but looking forward into what could happen when these technologies are ready. So we're certainly taking still inspiration from web because they are moving very fast, but not fast enough so that you can do something today. Any other questions?
Yeah. So regarding the exit state of the application, how do you plan to persist it?
So how could you persist the exit state? This is either implementer specific or the worst case scenario. Let me see where we're looking at this. The exit state is given by the application itself. So let me go back to the slide, the API that we have here. It's right there. So in order for you to persist that exit state, you had to provide a custom implementation of the application interface. That custom implementation most likely is going to be based on a base class coming from the implementer. Say the Griffon framework gives you access to an implementer of this application. The only thing that you need to do is create a new subclass and override the shutdown method called super on it. And once you got the value, you persist it directly using serialization or database or something else. Now, of course, this has to be done in a way that doesn't really take so much time or resources, because by this time you're supposed to be really, really already done with everything that you need to do. Okay. Hope that answers your question. Well, so again, thank you very much for your time. I hope that you found the talk to be interesting at the very least. And let me remind you, we're still working on this JSR, and we really, really would like to have more people joining and giving us information about the experiences they have in the past and what they would like to see in order to make their future experience a much better one. So, thank you.